my dear students. Asymptotic notation. So going back in that topic, since we've already discussed that in our data structures and algorithm last or previous semester. So yes, Mr. Galdosent, what is asymptotic notation?
Daw into tani bala.
The mic is yours, Mr. Gerdo.
Yes, if you can recall, what is asymptotic notation? Are we done in this part? Okay. Any idea?
Ang mic, sir, ang mic. We can hear
Yes, Mr.
Ang mic.
Mr. Chair?
Yung mic.
What is asymptotic notation? Mr. Cost?
Kirk? Is there time to shine? Let's see!
Okay.
Asymptotic notation deals with the higher bound and the lower bound of the type of activities and space. Yes, let's go!
Okay, very good. So, asymptotic notation, those are the mathematical tools that used to analyze the performance of the time, spaces, complexities. So, let's actually dive in onto the purpose of notation. Are we done with this part? Are we done? Okay, so the purpose of asymptotic notation includes to predict the performance and to compare such algorithms. Then we have to simplify the analysis. And we will also analyze the algorithm efficiency and to classify its complexities and to abstract the details. So each algorithms in our data structures before last semester, there is a specific time and spaces complexity. If it is belong to big O notation, big theta, or omega. So that refers to the upper bound, lower bound, is it average case model. So let's try to deal with that one by one. Yes, Mr. Abadi, what is big O notation for you? Since we are done with that last semester, but we are not able to break through. Okay. How about you, Mr. Taliado? That is talking to or for focusing to the upper bound limit for the time and space complexity. What about for the big omega, Mr. Villegas?
I think it deals with the lower bound type of complexity of the algorithm.
Okay, what else aside from that, Ms. Kasaipan? When we talk all about big omega, okay, good. So in our data structures and algorithm, that is talking to the lower bound itself. And what about the big theta notation? Yes, Ms. Bernal. The average case of these specific algorithm. So let's try to run through one by one. Big O notation that gives an upper bound for a function f of n within a constant factor. And that gives the worst case complexity of an algorithm, and that describes the asymptotic behavior of a function, not its exact value. Since of course, class, in our big O notation, there will be a lot of specific types. If you can recall, what are those? Since in our big O notation, linear rhythmic time, constant time, Okay, so those are the complexities or focusing to the time and space complexity. Since as our input size of n grows, what will happen? As our input size n, there will be a specific, it could be O of n, O of 1, O of n log n, 2n, n squared, diba? If you can recall. So let's try to check how does it work for per notation type, big O notation. So there will be a that is denoted, or we write the function of n, which is equals to the O or the big O of g of n. And if there are positive constant for the n0 and c, which is our c, that is our constant, and our n0, that is the threshold or the value, which is the value of your n that we are trying to prove, for example. And such that the inequality for this is we are focusing, or we are proving big annotation. Where? Sa ako na rin ano? Sa ako na whiteboard man, wala na siya ano di? Wala na siya annotation na yan. Ang whiteboard, mag-consume sa whiteboard ba? Malaw, ay. Mark. Lisa Martin.
Martin! Hindi daw pwede ito si
Hindi sa record na ba yun? Ito
guys, sila. That's one.
May annotation isa din na makasulat ka while ano? While ga-present.
Let's go, Martin! Our Savior! Martin! Dr. King.
Hindi, magwala dito sa presentation. Maayos chance ha? Why, gagawin na lang sa PC.
Okay, so anyway, we are trying to, ano na siya gani? So our focus here, we are trying to focus, or we're trying to prove the inequality of our big O notation. So the big O notation do have inequality that our f of n must be less than or equals to the value of your constant times or multiply with your g of n. And for all of your n must be greater than or equals to n0. So in our g of n, that must be or will align to the inequality. So hindi siya pwedeng ang imong f of n makontradict sa rule. It will not prove our O notation. So each of our notation, type of notation for O notation, for linear time, linear arithmetic, there will be a specific example how to prove those cases. So say for example here, suppose that we have our f of n example, which is before n plus 6. So how can we prove that our notation or O notation will be true, or the inequality, since our focus f of n must be less than or equals to the g of n. So you have to just distribute everything. So for example, you have your c is equals to 20, then 0, which is your which is 1, then you distribute that. By the way, through that values, does that contradict or is it true? If you may Think about that.
Kusog sa aircon to. Ginakuro ko dito. Ano lang, pahinay lang? Or isa lang paandara? Gani.
So, is it true or not? 4n plus 6. Then your C is 20. So this is our C. And if we will calculate our n, which is 1, so 20 times 1, then 4 times 1 plus 6 is 10, then 20. So does that contradict or is it true for the inequality?
True.
So that is true. So our example, that is considered as what kind of notation? Or time, I mean. Yeah, that is big notation. That is focuses to what?
Linear.
Okay, that is focuses to linear time complexity. So here then, the common big O notations that we do have, those are the big O notation, constant time, logarithmic time, linear arithmetic, quadratic, and exponential time. So if you can still remember, what are those formula, or how can we denote constant time? O of 1. What about linear arithmetic? What about logarithmic? Log n. And what about, and since near time, O of n? How about quadratic? And squared. And exponential? Okay, let's try to prove all about the specific time. So focus us to constant time. The runtime here remains constant regardless of the input size. So say for example, if you are trying to access or trying to search a specific element in your array, for example, you have specific check. Okay, so for example, you have a specific array right now. So if you want to specify the address of that, must be constant. You can search that constantly, or there will be a specific time. So now, this allows us to create predictable algorithms in situations where performance and responsiveness play a vital role. And the example for that is to access an element in an array by its index. So if you will access the 3, does that run? If we have that array? No, away. What about O of 1? And what will be the element? Huh? Okay. Yes, Mr. Robs. If we are specifying the index value, which is 1, that is 20. So that is, since we are trying to access the specific index, so we are trying to achieve 20. But if you are using 3, then this will be your array right now. We cannot access any element since only 3 elements, and that is 0 to 2 index. Now let's try to prove the constant time using this example. I want you to prove this problem. Okay, suppose 1, then okay. Okay, So this one, if we were going to implement in our constant or C, I want to put number 10. Does that result to true inequality or false? Why?
Because 10 is greater than 1.
Okay, good. What about if we will be going to put in our constant 0, what will happen? It will? Okay, false. So, in this example here, f of n is your O of 1, and we want to prove that the inequality must be less than or greater than, less than or equals to c times g of n. Then we have 1 for f of n and 1 for g of n as well. So we specify 3, so therefore this is equals to the inequality, or 2. Alright, so gets lang? Okay lang, easy pa man na. Now how about for logarithmic? So as you mentioned earlier, for logarithmic time, that is denoted as log of n, or logarithmic of n, which certainly occurs when an algorithm reduces the problem size at each step by a constant factor. So, by the way, it is often seen in divide and conquer algorithms to provide where the input size is repeatedly halved. So, by the way, pertains to divide and conquer algorithm, what is the specific type or example of algorithm that perform this divide and conquer, especially in sorting, if you can still remember? Yes, Mr. Toriano? Huh? Merge sort. Why merge sort is performing divide and conquer algorithm? Hayoma. Why is that considered as an example of divide and conquer? Okay. All right. So yes, that is the best example for divide and conquer algorithm. Since we divide the specific array into smallest term, and then we will begin to sort that out afterwards. So we bound specific after you divide, diba? If you can recall the merge sort. And that is somewhat, ano man, is it, dugay? Hindi. What specific time of O notation which is to hassle? To solve. Anong pinaka-hassle i-solve how if we are talking to time? For those time cases. Quadratic, why? Exponential. Yes, since there will be a lot of breakdown, especially for bubble sort. Since one wrong move, isa lang kasala, dead. Diba? If you can still remember your final term, you know, amazing. How about quick sort? Hopefully that we can talk a lot about the quick sort for each cases, for those leftmost and rightmost, then performing the horse method and the other method. Hopefully we can do so that you can also check the differences between those applications. Now, it is very efficient for large input. Why is it efficient for in terms of logarithmic time for large inputs? By the anyway, Italians. Why? Huh? I can't hear. In a divide. So if you can imagine, unlike with bubble sort that we are comparing two elements at a time, but in our merge sort we divide, then we conquer. So it is not time consuming. Unlike with bubble sort that it is n-1 iteration and n-1 step. So it is really hassle for you to solve those cases. Now, we have here a specific example of logarithmic time. Okay, let me show you this one. All right, I wanted to prove this, sorry, Dula. Okay, so kindly prove this equation, this problem, if this is feasible for if that prove our logarithmic time. So suppose that you do have for g of n log of n base of 2, then your c that is 2 and your n is also 2.